I'm a scientist, musician, artist, entrepreneur, many things. So you'll have to actually forgive me. I did my PhD work. I graduated in the end of the year 2015, and I've been involved in a lot of other projects since then. And so one of the symptoms of that is that you have to revisit topics as you move on from them, and it's sort of a beautiful thing that you can compare different realms, but it's also interesting to kind of go away and come back to things. So I'll be revisiting my PhD thesis research with you today to tell you a little bit more about what I've done. So one of the big questions that I asked in my PhD research was, why does music sound musical? And also, I was in a lab that studied birds, and so we wanted to kind of think about if birdsong had anything to do with music, except for our intuitive thoughts that it did. And birdsong sounds musical to us. Does it sound musical per se to birds, and if so, why? We followed quite closely an expert in the topic of music and music theory by the name of David Huron, who wrote this interesting book called Sweet Anticipation. And I'll give you a little bit of an overview of some of the ideas about the structure of music that he proposed and that we took from there and put into the studies that I did. So one thing that makes music sound musical, we believe, is this a delicate balance between expected and unexpected. So for example, we derive pleasure in listening to music from the fact that there's something expected about it. There's a form, or there's some repeated element that comes back, some theme that we can latch onto. And at the same time, we don't want something that's too repetitive, it gets boring. So we need some sort of variation. You hear the term variation on a theme, for example. On the other end of the spectrum, if something is completely unpredictable and there's no structure to it, we don't find that musical either. Our brain just can't latch onto the structure when we get distracted from what's going on. So the idea is that music is a balance between those two things, repetition, variation, the unexpected and the expected. And so we're exploring the question here of how birds might appreciate their music, their structures, their song structures, like we appreciate music. And so I looked at the song of this bird called the Australian pied butcherbird. It's called the butcherbird because it has this very sweet song, but in contrast to that, it has this sort of violent way of living where it impales, it's a carnivorous bird that impales its prey on the barbs and thorns of the Australian countryside, and uses those barbs and thorns to help rip those things apart. That aside, the song of this bird is very beautiful, and hopefully the sound comes through here. Let's test that out. That's just one of the phrases of one bird that I studied, and what you're seeing right here is a sonogram image of that, a black and white representation where the axis that goes up and down is the frequency, and then time, of course, is on the x-axis. And I'm just going to play that song slowed down because we want to try to understand the content of that phrase a little deeper. Okay, so you can see there's maybe even more to it than we originally heard at the regular speed. So here what you see is actually 5 phrases of the bird in the order that the bird sang it, and you can see we use this sonogram structure yet again. I won't play you each of these songs for the sake of brevity, but you'll hear them later. What we did was we actually transformed the representation, the visual representation, into a color map in order to better facilitate comparison between phrases. And now remember, one of the things that I'm looking for here is this sort of musical character of having something that is regular within the structure of what the bird is doing, as well as a component of variation and some sort of indicator that there's a intention, if you would say it, to balance those two things. So in order to look at the structure, we change these into color maps where color now is pitch. So the red color here is like a higher pitch. If you see the color bar at the bottom there indicating the frequencies corresponding to color, and the very blue color is a low pitch except for the darkest blue, which is silence. So you can sort of see how those colors and sounds align with each other. Do you guys want to hear more of this right now, or should I move on? Show of hands, would you like to hear these phrases? Okay, I'll do that. So the first phrase, and you can follow along there. So you see there's higher dark lines, those are higher pitches, and where they're lower, and where you see the sort of spotted part there, that would be kind of a tremolo. And I'll play them and we'll follow along. So this is the first phrase. Oops. Okay, the second phrase. Here's phrase 3. Phrase 4. And finally, phrase 5. So hopefully you get a good idea of how those maps correspond to the actual sounds. Those of you who play music or read music might have some more intuitive understanding there. But for the sake of this comparative analysis of the different phrases, what we did was we took these color maps now, and having these color maps facilitated the ability to visually compare the frequency spectrums of the different phrases to look for these interesting patterns that might indicate this balance of regularity versus variation. And so this is 5 phrases that we've done this with, but the bird might sing 250 phrases in a row, all sort of uniquely sung phrases with a pause in between. And so if we stack those all on top of each other, it might look something like that. When we see this image, there's sort of a very striking kind of intuitive idea that there's some uniformity there. There's some regularity going on. Is it just a couple of phrase types that just get repeated over and over again? Is that why it looks so regular? I think intuitively at first blush you would think, oh yeah, the bird has just a couple of phrases that it repeats, here and there, and that's why things look so uniform.